Welcome everyone to Algebra 2, Section 2.6, Quadratic Formula and the Discriminant. So let's start by this warm-up. Number 1, solve by completing the square, recapping what we did in Section 2.5. First step here is to make sure it is a 1x squared, which it is. Second step is to move the c term to the other side and make sure a and b are on the left. A and b are on the left, we have to move the c by subtracting 8. So I'll get x squared minus 10x. I'm going to go and put my plus blank there that I know I'll have. Equals negative 8 plus blank. Now to figure out what goes on the blank, I take half of my b and square it. So half of negative 10 is negative 5. Square that to get 25. Now I will factor my left side into x minus 5 being squared. It's always going to be the variable x and then half of b and square. Equals on the right side, negative 8 plus 25, which is 17. Now we square root both sides, and we end up saying, okay, well, we get x minus 5 equals positive or negative square root of 17. Ran out of room, so I'm going to continue on elsewhere. I'm going to add 5 to both sides and get x equals 5 plus or minus the square root of 17. And that's it, because we can't simplify the square root of 17. Number 2, let's simplify this. It's negative 4 plus or minus the square root of negative 248 over 12. Okay, well, the first step is to simplify this radical. Figure out what goes into 248. That's a perfect square. So I'm going to get the negative 4 stay the same, plus or minus. I'm going to call this the square root of 144. Maybe not 144. Let me try that again. Square root of 4, the square root of 62, and the square root of negative 1 over 12. Now I'm going to call that over here negative 4 plus or minus 2, which is the square root of 4, I, the square root of negative 1, and the square root of 62 over 12. And I can actually reduce this 12 with both that 4 and 2i, if you recall. And I'm going to do just that and get negative 2 plus or minus I times the square root of 62 over 6. And we could actually separate these out even further into two different fractions if we wanted to. Continuing on, letter B, negative 2 plus or minus 4 minus negative 10 over 2 times 15. Okay, well, we got to complete some operations in here and down here first before we go any farther. So really, two negatives is like we're adding. So you have 2 plus or minus the square root of 14 over 30. Well, the square root of 14 can't simplify at all. We're actually done there. All right, now on to the new stuff. So we have this thing called the discriminant. And the discriminant helps us identify our solution. So it tells us the number and type of solutions a quadratic formula has. Now, a reminder, a quadratic formula or quadratic equation, quadratic equation has. Quadratic equation is ax squared plus bx plus c. Now, the value of the discriminant is, well, let's first of all get into what the discriminant is. The discriminant will be whatever b squared minus 4ac is. B squared minus 4ac. B squared minus 4ac. And that comes from our a, b, c. So if the result of b squared minus 4ac is greater than 0, aka it's a positive number, because any positive is greater than 0, then you are going to have two solutions that are both real solutions, aka not imaginary. And your graph will look something like this. Not identical necessarily, but something to where it crosses the x-axis twice, because that means there's two real solutions. One real solution for every time it crosses. Now, if your discriminant, the b squared minus 4ac, is exactly 0, not negative or positive, you will have exactly one real solution. That's it. So your graph might look something like this. Where it crosses the x-axis exactly once, right where it touches it. Last but not least, if your discriminant is a negative, aka it's less than 0, you will have two non-real answers or solutions. That means they're imaginary. Now, if they're imaginary, they don't actually exist, so we don't have it crossing the x-axis at all. So let's find the discriminant and use that to give the number and type of solutions, like using this table. So on letter A, x squared minus 6x plus 10 equals 0. Well, a good tip, especially as we're starting these out, is to identify A, B, and C. And as long as it equals 0, which it does, we can identify them well. A is 1, B is negative 6, and C is 10 because it's with x squared, the x, and no x. And reminder, we are doing b squared minus 4ac. So b squared, that's negative 6 squared, minus 4 times 1 times 10, 4ac. Okay, so negative 6 squared is a positive 36 minus 40, because negative 4 times 1 times 10. That ends up being negative 4. So according to our table, that is less than 0, aka a negative number, so we have two non-real solutions, meaning it to be a graph that never crosses the x-axis. Go ahead and try letter B on your own, and then continue on with the video once you have it, or get stuck. All right, here, A is 1, B is negative 6, and C is 0. After this problem, I'm actually no longer going to be writing out what A, B, and C are equal to. Plug that into b squared minus 4ac, and you get negative 6 squared minus 4 times 1 times 0. Well, that's 36 minus 0, because 4 times 1 times 0 is 0. And that would result in 36, which is a positive number, meaning we have two real solutions, and our graph would touch the x-axis twice. I recommend doing the same thing on C as you did on B, where you try it alone. All right, so as we do b squared minus 4ac, we get negative 6 squared minus 4 times 1 times 9. And we end up getting 36 minus 36. That is exactly 0, which is our middle scenario, where you have one real solution. So it'll just barely touch the x-axis, like in an example we see here. Now, here we'll have a word problem diving into the same concept. A ball is thrown into the air with an initial velocity of 14 meters per second from an initial height of 2 meters. The ball's height, h in meters, and at time t in seconds can be modeled by the quadratic function h of t is equal to negative 4.9 t squared plus 14t plus 2. Write an equation and determine if the solutions are real or non-real to answer the question. All right. So here we need, excuse me, what we need to do is we need to plug in 2, excuse me, not 2. We just need to take, the negative 4.9, the 14, and the 2 as A, B, and C, and do the exact same thing as we were doing with b squared minus 4ac, and see if we get a positive, a negative, or 0, because that'll help us know if they're real or non-real. We don't actually need to solve this problem to figure out what time it hits, what height will it be at for the maximum, or anything like that. We actually are not concerned with that at all. All this other information, the 14 meters per second and the initial height of 2 meters, just helped us form our equation here. So we plug that stuff in and we get 14 squared minus 4 times negative 4.9 times 2. 14 squared is 196. On the right there, negative 4 times negative 4.9 times 2 ends up being a positive 39.2. So then we combine those and we get 235.2. Well, are the solutions real or non-real? Well, they're real, and there's going to be 2 of them. But we were just asked to determine if they are real or non-real. So once again, we just said, hey, we actually don't need to solve this and figure out what height is the maximum or anything like that, or how long it takes to get there to 0 and hitting the ground again or anything like that. Like we did earlier this chapter, we literally just need to do b squared minus 4ac using those numbers. All right, now we're going to get into the actual quadratic formula. Woo, quadratic formula. So when a quadratic equation is written in the form ax squared plus bx plus c equals 0, it has to equal 0. And a is not 0. What that means is if a was 0, by the way, is it would be 0x squared, which would just be 0. So you wouldn't have an x squared. AKA, as long as you have some sort of x squared, you're good. And then we can solve it using the quadratic formula. X is equal to, you'll want to memorize this one, by the way, negative b plus or minus the square root of b squared minus 4ac all over 2 times a. I will link a video in Google Classroom of a song for the quadratic formula that if you had me as in Algebra 1, you probably remember a little too well. So this formula is a formula that will work for any quadratic. We've done with problems where we tried factoring, and well, you can't solve every problem by factoring, we said. Okay, and we did problems where we solved it by square rooting, and we said, well, we can't solve every problem by square rooting either. Okay, well, we did problems where we do completing the square, and we're like, well, sometimes completing the square gets really messy if we create a lot of fractions in there. Okay, well, quadratic formula will work for every single quadratic out there. If it's a quadratic formula will solve it. The thing is you might be wondering, well, Mr. Kossel, why don't we just only learn the quadratic formula? Why do we bother with all the other ones? And that's a great question. The reason why is the quadratic formula is a pretty big formula if you weren't understanding that or weren't sure on that. It's pretty big. And so there's quite a bit of steps to do. Numbers get pretty big, and it takes a bit more time than some of the other methods do. But it will always work. So it's kind of like using, instead of just like a normal like table knife or a butter knife to like spread butter or peanut butter on toast or something like that. Of course, I say peanut butter, given that's my favorite food. The quadratic formula, using it to solve a more simple problem that you could solve by another method more easily, is like the equivalent of, instead of that scenario with a butter knife, using like a steak knife or like a machete or a sword to spread like something on toast, like to spread butter on toast. Yeah, it would work, but it's way more than you need for the job, and that might actually end up making it more difficult to try and use one of those other tools on it, even though it does work. It's just a little more powerful, you could say, than you really need for the job. All right, so as far as actually using quadratic formula now, we have to identify a, b, and c, which we already actually started out doing. And we want our answers in exact form, by the way. So we want like no decimals, which is something we've been doing all chapter. We haven't dealt with any decimals for our answers all chapter, just square roots and perfect squares. So we put the equation in standard form. Reminder that standard form is ax squared plus bx plus c equals 0. Then we put values into the quadratic equation, the negative b plus or minus b squared minus 4ac over 2a, and we start solving. And we're actually going to start solving exactly like this. You might notice that's a lot like the quadratic formula. negative b plus or minus the square root of b squared minus 4ac all over 2a. And this one got even more similar to it, where we had to actually multiply numbers and have 2 times a and stuff like that. So let's practice here. This is not in standard form because it equals 8. Subtract 8 to get 3x squared plus 10x minus 8 equals 0. Now, just like earlier when we were doing just the discriminant, I'll write out a, b, and c what they equal to on the first couple. And after that, I'm actually going to stop writing it. So a equals 3, b equals 10, c equals negative 8. Now, if it's helpful for you to continue to write out every single problem, write it every single problem. I also suggest for your first few problems, or really until you actually genuinely start memorizing the quadratic formula, because it's something you need to memorize, to write it down on each problem. X equal to negative b plus or minus square root of b squared minus. So now what we'll do is we'll take the a, b, and c and plug it in. So x is equal to, and I would write small to give yourself enough room, and also don't write super over into this area yet. Maybe keep it more over here, so that way we can move over here if we need more room. Just some tips here. So negative b, negative 10, and I'd suggest putting things in parentheses to start until you get more used to it, is plus or minus the square root of 10 squared instead of b squared, minus 4 times ac, so 3 times negative 8, all over 2 times 3. You also might notice, by the way, that this underneath the square root, the b squared minus 4ac, that's the discriminant that we were working with earlier that told us, hey, 2 real, 1 real, or 2 non-real or imaginary. All right, now that we got it plugged in, we simplify. Negative 10 is negative 10. Plus or minus 10 squared is 100. Negative 4 times 3 times negative 8 is positive 96. On the bottom, we have 6. Okay, continue simplifying, and we get x equals negative 10 plus or minus the square root of 196 over 6. The square root of 196, we actually know that, thankfully, so we don't have to say it's the square root of this times square root of this. It's actually just 14. Now, from here, we can split our equation and solve, because that was a perfect square. Remember, whenever we have a perfect square, we want to split the plus minus into 2 different scenarios. So I'm going to do that. I'm going to do x equals negative 10 plus 14 over 6. And I'm going to do another one down here, x equals negative 10 minus 14 over 6. Now, say I'm solving this top one first. I get 4 over 6, which is 2/3. That's one of my answers. My other one, I get negative 24 over 6, which ends up being negative 4 is my other answer. So those are my 2 answers. And because my b squared minus 4ac, what's underneath the square root, was positive, I had 2 answers. All right, quick recap. I had to start off by solving for 0, or setting equal to 0, excuse me. Saying, hey, plug it in the quadratic formula, negative b plus or minus b squared minus 4ac all over 2a. And then from there, I just had to simplify, do my order operations, handle everything underneath the square root in order. Do the square root if I can, otherwise I simplify if I can. And then do any more math we can. In this case, it was a perfect square, 14 was, 196 was, I should say. So we were able to continue by splitting it. Letter B, x squared minus 10x plus 8 equals 0. It's already equal to 0, so we just identify a, b, and c. A is 1, b is negative 10, c is 8. I would encourage you to try to do as many steps as you can without watching the video first, and then coming back and watching the video after you write the step down. So x is equal to negative of negative 10, yes, that's 2 negatives, plus or minus the square root of negative 10 being squared, minus 4 times 1 times 8, all over 2 times 1. Two negatives may end up making a positive 10, plus or minus the square root of 100 minus 32 over 2. From there, you get 10 plus or minus the square root of 68 over 2. Now 68 is not a perfect square, so we turn to simplifying it like we've done before. 10 plus or minus, and perfect square that goes into 68 is going to be 4. So it ends up becoming 2 times the square root of 17, because it's the square root of 4 times the square root of 17, over 2. Now, it can be helpful to think of it in really one or two ways, okay? You know what? I would actually encourage you to make it two different fractions like we did before. Call it x equals 10 over 2 plus or minus 2 squared root 17 also over 2. That will help us see what's happening here. That, hey, we can simplify 10 over 2 and call that 5. We can simplify these 2's and just call it the square root of 17. So we get 5 plus or minus the square root of 17. And we can't continue any further because we can't add 5 with the square root of 17. So a quick recap here. Instead of splitting it into the positive negative like we did on the previous example, because it was a perfect square, because it was not a perfect square, we instead split the fraction and look to simplify. Example C, it doesn't equal 0, so we need to make it equal 0. I'm going to subtract 17x and get negative 40x, and I'm going to add 25 to get plus 25. I'm not going to write down my A, B, and C this time, but I want you guys to try as much of this problem as you can. And good thing we can use calculators because these numbers get a little big. X equals negative 40 plus or minus the square root of negative 40 squared minus 4 times 16 times 25 all over 2 times 16. That's positive 40 plus or minus square root of 1600 minus 1600 over 32. Ends up being 40 plus or minus the square root of 0 over 32. But wait a second, the square root of 0? That's just 0. And we don't need to write that it's plus or minus 0. That seems silly. So it's 40 over 32. And you might notice we're just going to get one answer. Well, that makes sense because our discriminant was underneath the radical. B squared minus 4ac is 0. So we say 40 over 32. Can that simplify? The answer is yes, it can. 8 goes into both numbers. 5 over 4. So we just had one answer because the discriminant was 0. On to letter D. Once again, I recommend doing as much as you can now and then continuing the video afterwards. Subtract the 7x from both sides, add the 3 to both sides. I get x squared minus 7x plus 3 equals 0. Plug it in to get x equals negative 7 plus or minus the square root of negative 7 squared minus 4 times 1 times 3 all over 2 times 1. That's positive 7 plus or minus the square root of 49 minus 12 over 2. 7 plus or minus the square root of 37 over 2. Now this one, you might notice 2 can't simplify with either of these, and it wasn't a perfect square. Last time it wasn't a perfect square, we split them up. We said, oh, hey, we can split these 2 up into 2 different fractions and simplify from there. We can't this time because there's no 2 or anything that can be reduced by 2, and same here. 7 can't be reduced by 2. So if you want to, you could split it up into this. 7 over 2 plus or minus square root of 37 over 2. Or you can just call this your answer. Because there's no more math you can even do to split by splitting it up like we could previously. And there's also not an imaginary part, because when there's an imaginary part, we do in fact want to split it up. E, once again, encourage you to work on as much as you can. I'm going to subtract 3 from both sides to get 3x squared, not cubed, plus 2x minus 3 equals 0. Plug it in. X equals negative of 2 plus or minus the square root of 2 squared minus 4 times 3 times negative 3 all over 2 times 3. Negative 2 plus or minus the square root of 4 plus 36 all over 6. X equals negative 2 plus or minus the square root of 40 over 6. Now, this one will be helpful to split up, but before I do, let's simplify the square root of 40. X equals negative 2 plus or minus 2 times the square root of 10. That's the case because it's square root of 4 times square root of 10 over 6. Now it might be a little bit easier to see. It'll be helpful because 2 and 6 can reduce on both of those. So x equals negative 2 over 6 plus 2 square root 10 over 6. So that ends up being negative 1/3 plus square root 10 over 3. So x is equal to negative 1/3. Let me write that negative 1/3 a little cleaner. Plus square root 10 over 3. I recommend you do example F as much as you can on your own. Example F already equals 0, so I'm just going to plug it in. X equal to negative 1 plus or minus the square root of negative 1 squared minus 4 times 2 times 3 all over 2 times 2. Positive 1 plus or minus square root of 1 minus 24 all over 4. X equals 1 plus or minus the square root of negative 23. That's a negative number. The discriminant's negative, meaning we should have two non-real answers. As we investigate that further, we notice x equal to 1 plus or minus the square root of negative 23 is really the square root of negative 1 times the square root of 23. The square root of 23 doesn't reduce. The square root of 1 is I, so we call it I square root 23 over 4. And we do like writing these separately, so we will write them separately and give us 1 over 4 plus or minus I times square root 23 over 4. And if we could reduce, we would, but we can't, so we won't. The reason we want to write these separately, but I said on our example D that we can if we want, but don't have to, is because this did not have an imaginary part. This one does. Continuing on. Let's apply this to a couple real-world scenarios. Woo! Formula for an object that's just dropped, so it's not thrown or anything like that. H of t, and this is a formula for like, how high you drop it from, how long does it take to hit the ground or be at a certain height, those kind of things. So it'll be h of t is equal to negative 16t squared plus h sub 0. You will not have to memorize this. Now, if it's being launched or thrown, then it's h of t is equal to negative 16t squared plus v sub 0 times t plus h sub 0, a little bit more. Now, h is the current height, so that's like h of t, that's like current height. T is the time in motion, and h sub 0 is the initial height. V sub 0 is the initial velocity. All right. Now, I wrote that as an uppercase V. That really probably should be a lowercase v, my apologies. But still bigger than the 0. So example 4, a basketball player passes the ball to the teammate. The ball leaves the player's hand 5 feet above the ground, has initial velocity of 55 feet per second. The teammate catches the ball when it returns to a height of 5 feet. How long is the ball in the air? All right, important information. We don't really know that they're passing the ball to a teammate, although the idea that they're passing the ball might be helpful. That tells us that there's force behind it. It's not just being dropped, which tells us to use this bottom equation. Ball leaves a player's hand 5 feet above the ground. That's important. Initial velocity of 55 feet per second. Teammate catches ball when it returns to a height of 5 feet. And we want to know how long is it in the air. All right, so let's pull information out of here. Since we have this equation, we need to try and figure out all the information we can. We want to know the initial height. We want to know the initial velocity. We want to know the ending height. And if we can, we want to know time. Those are our 4 variables that we have here. Well, we know the initial height. We're told leaves the player's hand 5 feet above the ground. That's the initial height, 5 feet. We know the initial velocity, it says here, is 55 feet per second. The ending height is 5 feet. And the time, we don't know that yet. That's what we're going to find. How long is it in the air? So we take these and we plug it in. This 5 goes for h of t equals negative 16t squared, since we don't know t, plus the initial velocity, 55 times t, plus the initial height, 5. That's our setup. Now, in order to solve this via the quadratic formula, we have to set it equal to 0. So, and I'm going to also switch my equation around as I do this. Just adds up. So I'll subtract 5 from each side. I'll get negative 16t squared plus 55t plus 0, so I don't have to write it, equals 0. Now, as we use our quadratic formula, we get x equals negative of 55 plus or minus the square root of 55 squared minus 4 times negative 16 times 0 for my c, all over 2 times negative 16. Well, x equals negative 55 plus or minus the square root of 3025 plus 0, so 3025 over negative 32. Now, we are going to do an approximate on this one. So you can just type this into your calculator, do the square root of 3025, for example. So as we do the square root of 3025, if you're using your phone by chance, if you're at home or something like that, or working during a study hall maybe and you have your phone, you can do that, or you can use a calculator, one of mine, whichever way you want to do it. And we say, oh, well, the square root of 3025 ends up being, well, 55. Because it was 55 squared. That makes sense. So we get x equals negative 55 plus or minus 55 over negative 32. So as we split this into a positive and negative, because 55 ended up being no radical as 3025 is a perfect square, we get x equals negative 55 plus 55 over negative 32. And x equals negative 55 minus 55 over negative 32. This one on the left, that's going to equal 0, because negative 55 plus 55 is 0. The one on the right is a negative 110 divided by negative 32. Well, a negative divided by a negative is going to be a positive. And negative 110 divided by negative 32, 110 divided by 32 is going to be approximately, not exactly, we have to round it, 3.44. Now, the reason why we did approximate instead of exact on this one, instead of just leaving it as some sort of fraction and reducing it, is because if we're running know the amount of time, we're not going to say time in a fraction. That's just not normal. We'll say, hey, it's 3.44 seconds. That's a more normal time for us. So how long does it take? It takes about, that was a terrible U, 3.44 seconds, or S for seconds. Last but not least, Haley here drops an egg from the top of a building 50 feet above the ground. We want to know how long does it take for the egg to hit the ground. Okay, we don't need to know it's Haley. We don't need to know it's an egg. But we do need to know she drops it, because that tells us it's the first formula. Dropped object, not something being thrown or launched. Okay, from the top of a building 50 feet above the ground. Okay, we want to know how long till it hits the ground. All right, in this first formula, our three things we can find are initial height, not initial velocity now, we don't need that because it's not being launched or thrown. The height when at a certain time that we want, and the time. Well, the initial height is going to be the 50 feet above the ground, where it's thrown from. The ending height hit the ground. The ground, that's at 0 feet. The time, that's what we're trying to figure out, how long until that happens, t. So now we take that, plug it into our first formula. 0 equals negative 16t squared plus 50. Put this in the quadratic formula and solve it. Cool. Now you can also solve this one by square rooting if you'd rather, just so you know. X equals, I'm going to zoom in here, negative of 0, because there's no b, plus or minus square root of 0 being squared, minus 4 times negative 16 times 50, all over 2 times negative 16. X equals plus or minus, because you don't need to write the 0 first, times the square root of 3,200 over negative 32. Well, square root of 3,200, okay? Well, we can figure out what perfect square goes into that, but we really don't need to, because once again, since we're dealing with time, we're okay with an approximate. So I'm going to take 3,200 and hit the square root button on my calculator and say, oh, okay, it's approximately positive or negative, and I'm going to go to, let's say, 3 decimals, so that way I'm going one farther than I will when I divide. 56.569. If you went 2 decimals or even 1 decimal, that's okay. I didn't give specific instructions on this problem. Typically, I'll say if I want it in a decimal, which is rare, to go to 2 decimals or to go to the hundredths or whatever. And that's divided by negative 32. Well, if we take the positive version and divide that by a negative, that's going to give us negative time. Time can't be negative. If we take the negative version and divide that by a negative, that's going to give us a positive. That's the one we want. So if we divide those two, we end up getting it to be approximately, not exactly, 1.77 seconds. So to answer the question, how long will it take? It'll take about 1.77 seconds. All right, that is section 2.6.